So if you check the review part in your chapter 10, you need to take a note that I'm skipping the conic sections part, so you can skip that for now, and also the hyperbolic function. I also skip that for now. So every questions that has any hyperbolic functions like sine h, cos h, you can skip that for now. Also the conic section, I also skip for now, because the chapter 10 for conic section is actually it's quite similar with your conic section from basic of math. So I'm skipping that for chapter 10. So you can focus on chapter, actually on chapter 10, you can focus on uh, 10.3, 2, and then 10.3, and also 10.4. 10.1 is just an intro, so you don't really need that. So 10.2 is the calculus on parametric, right? The chapter 10.3 is actually the polar, the intro to polar. If you are familiar with polar, actually you can just focus on 10.2 and 10.4. That is the calculus on parametric and calculus on polar. So if you read your textbook, if you want to exercise, you can take some exercise on 10.2 and 10.4. Okay. Okay. Now, to see the what is the question in 10.2, you will have a calculus on parametric, which means you will have the questions like finding dy dx, and then maybe the second derivative, equations of tangent line, right? Slope and etc. Same thing. Also the integrations, which means the area, but now the area is usually your area is y dx, right? And now it's become with theta. Uh, now it's become t. Usually it's for some x, and then arc length, and then surface, blah blah blah, right? Now let's try some example, okay, for the 10.2. Actually, I'm taking it from the chapter 10 review on your textbook. You can check later. I give you the PDF file for chapter 10. Okay, maybe from the first problem is find the slope of tangent line to the given curve at the point corresponding to the specified value of parameter. It seems long, but actually find the slope of tangent line to some curve at some t, just that. The curve, I will give you two curves. The first one is at t equal -1. This case is the parametric, right? Another case I want to check is the polar one. Let me check the R. We start from the very basic in chapter 10. Maybe I'm giving you a couple minutes to try and check your answer. Okay, so finding the slope of tangent line. This is the first question. This is the second one, the second curve. So you have the curve for x equals t cubed minus 6t plus 1 and y equal 2t minus t squared. And you need to evaluate at t equal -1. The second one is the polar equation r equal 3 plus cosine 3 theta. And you need to evaluate at pi/2. Okay. Finish. Come on, this is the basic one. Does anyone find the answer? Okay, I think it switch this. It's the XDY. If I answer number one, this. Okay, okay, okay. Okay, let me give you the answer. Okay, so first, the question about slope of tangent line is always asking about dy over dx. So it's asking dy over dx. And in parametric, it's actually quite simple if you see the relations. So dy over dx is, you can rewrite as dy over dt divided dx over dt. Okay. And you can remember the chain rule to confirm that this is correct. Okay. And later, we just differentiate each equation with t. So dy over dt is 2 minus 2t. Okay. And then dx over dt is 3t squared minus 6. And we need to evaluate at t equal 1, which is we are having 4 divided by 9. Wait. Minus, sorry. So this should be -3. Oh, yeah. Yeah. So some students are correct. Actually, the questions should be, this should be plus. So, but yeah, but I think that's okay. So I was making a mistake here. This question should be plus 60, but never mind. The question's still valid. There's nothing wrong here. So this is the number one. And number two is 3 plus cosine 3 theta. So same thing, we can make it with dy over dx, and it's also same thing with the what we've done before, but we change to theta. And we can write that x is r cosine theta and y is r sine theta. And both of this we need to differentiate. So this will be dr over d theta sine theta plus r cosine theta for y, and then for x is dr over d theta cosine theta and then minus r sine theta. And the next thing is you need to plug in all the information from the questions. So first, we need to evaluate dr over d theta is 0. So it's negative 3 sine 3 theta, right? So we need to exchange or replace all the r d theta. So negative 3 sine 3 theta, sine theta, and then plus 3 plus cosine 3 theta, and then cos theta. And then negative 3 sine 3 theta cos theta minus okay. Now you can stop here and just plug in theta equal pi over 2. So dy over dx will be, this will be negative 3 multiply with negative 1 multiply with 1 plus 3 plus 0 and multiply by 0. So it's 0. And negative 3, negative 1, and then 0. So it will be, this part is 0, 0. So 3 divided by negative 3 is negative 1. Okay, hopefully for this warm-up you understand the concept. Okay, I've give you the other questions that's still related to parametric. Find the second derivative. And to check whether you still remember the concept. X is 1 plus sine. Okay, just that. Oh, wait. Not 1, that's D. Of course, the next step from here is just finding the dy dx, right? Which is dy over dt divided dx over dt. And please remember, and always be careful, okay? Usually, a common mistake is because you write x at the first time, you are using x here. And your answer will be switching, right? And the other part that maybe you are forget to write is to write the second derivative. So you get d over dt, dx over dt. And then the second derivative, you are deriving this and deriving this. And that is wrong, okay? To remember what the second derivative means is, let me write here. This is actually from this. Okay. So it's not just like Okay, because the first derivative you are derive y with t, derive x with t. If you are going to second derivative, maybe you are thinking, okay, derive again one more time here and one more time here. And what is wrong is because your y and your x both are having relations with t, right? But you are asking to find the differentiations of y with respect to x twice. So it's different. So you need to mention that it should be related to dy over dx. Okay. So why we need to write like this? It's because of chain rule. Not because okay, first derivative. Okay, second derivative from here. Okay, that's wrong concept. Okay, wrong concept. Okay, now for the question, so we need to find dy over dx, the first derivative from x and y, and put into our equation here, and that is becoming our slope, right? And from that slope, we need to differentiate once and then divide by dx over dt, and that's it. That's the answer. So maybe I will write here. So dy over dx is t minus cos t is becoming 1 plus sine t, and then divide by x is 1 plus cosine t. Okay, now we have the dy over dx. Now we are putting here, so the dt 1 plus sine t divide 1 plus cosine t, and then divide with 1 plus cosine t. Now differentiate, we have the quotient now. Remember the quotient rule. So the 1 plus cos t will be having squared. And then this will be 1 plus cos t, and then cos t. And then minus the 1 plus sine t, and then multiply with negative sine t. And this will be 1 plus cos t multiplied by cos t will be cos t plus cosine squared t, and then plus sine t, and then plus sine squared t. And divide by 1 plus cos t cubed. Now this and this become 1. So we can write 1 plus cos t plus sine t divide by 1 plus cos t cubed. Okay, any questions? Okay, let's continue. Let me move to the next page here. And let's see. Okay, now the 10.4, usually you have the uh, polar curve and you need to find the area. So let's try that question. So find the area of the region that lies inside both of the circles So new thing, what is the shape? I think because the question already mentioned, both are circles. Okay. So again, to help you draw, my suggestion is just using the uh, try some theta from 0, pi over 2, pi. At least you get the intersection of the polar axis. So first, after you get the idea what's the circle looks like, the next thing is let's say that inside both of their circles. So probably the circles will be having intersections, right? So you need to find that intersection. The intersection will help you to define which area you want to observe. Okay. And for this sine theta plus cosine theta, uh, another thing that you need also to mention is remember that sine and cosine, they have different characteristics in terms of their quadrants. Okay. Cosine will having uh, positive in 1 and 4, right? Sine is having in 1 and 2. So the circle is not exactly cutting the axis in symmetrical view. So some will be crossing the x like this. And you need to also to think, because it has the same theta here. So of course, if theta is 0, sine is 0, and cosine will be 1. Same thing with pi over 2. This will be 1, this will be 0. So the optimum theta will be 45 around, right? So at 0, this is maybe here, and at 90 will be here. And if you check some special value, you will get at least like this. The so it's crossing the 0 here, crossing this at here, and this will be the circle. And this value is theta pi over 4. Yeah, you can check it. Okay. These terms, the quadrant 4 and the second quadrant, is because of sine and cosine. They have these characteristics. Okay. So in here, cosine is positive, right? And sine is negative. And here, sine is positive and cosine is negative. So I think another confirmation is you can check from this pi over 6 and maybe this pi over 3. You can check their value. Okay. Is it confirming that this is true or not? Okay. Aside from confirming this 0, pi over 2, pi. Okay. Now you can draw the circle. Okay, maybe like that. And the second one, the circle, is 2 sine theta. So twice of the circle, but the position is here for 2 sine theta, right? Let me move a little bit down, going here. Okay, I think already good. So the question is asking the area inside both of the circles. So both of the circles, this one and this one. So the area will be here. Okay. Okay. So this will be the area. Let me just make some marks here. Okay, that's the area. Okay. And now we need to find these intersections. Also this. Okay. And we just make some equations equaling the polar curve. 2 sine theta equals sine theta plus cosine theta. So sine theta is equal cosine theta, and we are achieving this equations because of theta is pi over 4, right? So this will be pi over 4. And also at this origin, this will be theta equals 3 over 4. And now to calculate, let me draw. So this is theta equal pi over 4. Let me make new line. Okay. Now first, we will have two area. Okay, two area. So let's check. This is 1. This is 2. So first, we need to check the area 1 from 0 to pi over 4. Okay. And then the second one from pi over 4 to 3 over 4 pi. This the same with the origin. Okay. So we are having like a one loop, right? One loop of circle. So from 0 to pi over 4, and from pi over 4 to 3 over 4 pi. So that's just using this theta in our equations. So area, the first is the bottom one is the 2 sine theta, and the top one is sine theta plus cosine theta, right? So the first one with the theta from 0 to pi over 4. Let me make, I think I need to make it bigger. So it's 2 sine theta. So the area will be half, and then 2 sine theta squared d theta. And then plus the area 2 from pi over 4 to 3 over 4 pi. And that will be half, and then sine theta plus cos theta squared d theta. Okay, now it's actually for calculation, it's really nice. Okay, another point to make: if you see any integrations and you see any squared form, you need to change to the double angle formula. And that way it will be easy to integrate. Okay. So here, let me make the double angle formula for you. You can choose between this or this, right? Wrong. It should be sine, and this should be cosine. Okay. So now we already have 2 sine squared. This is 4 sine squared, 4, so it becomes 2, right? So 2 sine squared is the whole thing here. So we can change to here, which means we are having 1 minus cosine 2 theta, right? So we change to so this will be 1 minus cosine 2 theta, and then d theta, and then plus. Okay, from here, you see that the sine squared and you have cosine squared, it will become 1 plus 2 sine cosine, right? So this will be half, okay? And then inside will be 1 plus, it's sine 2 theta, right? And d theta. And now we can integrate with theta. So area, so this will be theta minus sine 2 theta divided by 2. Plug in 0, plug in pi over 4, plus, this will be half theta, and minus sine, cosine, sorry, divide by 4, right? And then plug in pi over 4 and 3 over 4 pi. And you can check the answer. And the answer will be half pi minus 1. Okay. Okay, so because we are already on the half of our course today, I will move on to chapter 11. Okay, and you can check chapter 11 review on your textbook if you see your textbook. And so today I will just focusing on the textbook review, chapter 10, chapter 11. Next Monday, we will have another exercise. I will focus on some question from other midterms, other exam as well, and still focusing chapter 10, 11. So we move to chapter 11 now. So what we did before for chapter 10, that is the summary for parametric polar. What you need to do is you need to use most of the calculus, and you need to remember the concept when you change the Cartesian into parametric and polar. What's the difference in the calculus part? The derivative, the integrations, arc length, and so on. And that point you need to remember. And the rest is you need to use some algebra to simplify the calculations. Okay. Okay, now we move to chapter 11. So chapter 11, most of the case is you will have the first is sequence. Okay. The second is series. Sequences is just a set of order, right? So you have let's say AN, and you will have A1, A2, etc. AN. Right? But for the series, you have the set of order, but you need to plus all the set of numbers here. Now, the typical problem in the sequence and series is finding whether the sequence or series converge or diverge, right? Let's just start with the sequence. Okay, let's start with the sequence. Okay, let's say we have the questions determine whether the sequence is convergent or divergent. If converges, find its limit. This is very basic for sequence. Let's say the sequence is let's start from the very basic and simple. Okay. Now determine whether the the sequences, you have three sequences here, whether it is converged or diverged. If it is converged, find the limit. Okay, so first thing, to find whether the sequence is converged or diverged, you need to find the limit of the sequence, right? Find the limit as n approaching infinity. And if you have, or if you find that limit is approaching some value, then it will be converged. Okay, so the first one, I think it's not too difficult. You just need to use limit and then approaching infinity. And because you already see both having the n cube, so we can directly, this is going to half, right? And the second one is cosine. For cosine, you need to try several n, right? From n equal 1 equal 2. So when n is odd, like 1, 3, 5, it will be 0, right? Cos 5 over 2 is 0. But when n is 2, from 2, 4, and so on, it will be plus minus 1, right? So because, let me write, because n is, or maybe write if n is odd, an is 0. If n is even, an is plus minus 1. So because it's having the plus minus 1, so the sequence going up and going down constantly, right? So we can say that um, sequence of an is diverged, and this is converged. So it's diverged, right? Now the last part is we need to evaluate this, and because it's um, infinite over infinite situation, we can use L'Hopital rule. And this will be 2, which is 0. So it will be convergence. Okay, now try this series. Maybe like this. Let me change it. Okay, these three. I hope we still have time to check the other. We're giving maybe a couple of minutes for you to try. What is this? Oh, N? Okay. I cannot read your writing. Okay. I think the first one is basically, so number one here, okay, every time you are seeing this series, the first thing you can do is try to limit the sequence inside the series, right? So if this is n, and then 3n plus 1, if you can find that this is actually getting a number, so in series, this will be diverged, right? We call this test is divergence test. Okay. So how to make sense to your understanding? So in sequence, so if it's the sequence is A1, A2, A3, and so on, right? In sequence, if your sequence getting some value, then it will be converged to one value, right? But in series, okay, in series, because you are plus your A1, A2, A3 until some infinite n. If you plus 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 and you are having a constant value, then of course it will be going to be diverged. Okay, that's the thing. So that's why when we have the limit of the sequence, it's going to have some value, then the series will be diverged. Okay. And then if you have the limit, it's going 0. Is it converged? Not necessary. Okay. It may be converged, but you need to test or confirm with other methods. Okay. So when you have a value, it definitely will be diverged. But if you have 0, it might be converged. But you need to try with other tests. Okay. So might be converged, but not necessarily be. Okay. And the second one, you have um, multiplications with it's the odd number, right? Divided by 5 with power of n and n factorial. Every time you see factorial, just blah 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 multiply. The first thing you can come up is ratio test. Okay? Ratio test. Okay? Definitely ratio test. Okay? Every time you see factorial, go into ratio test. I think every time in your textbook you have factorial, you can go to ratio test. Okay? So go to ratio test. Maybe right here. So okay. Usually I'm just calculating the ratio first and then using the limit at the end. But if you want to write the limit here, that's okay. So this will be so we will have let's write the limit here. 2n plus 1 divided by the factorial and plus 1 and then 5. Oh, 5. Forget 5. So this will be 2 over 5, which is less than 1. So by ratio test, the series converges. The last one, let me write the question one more time. Okay. Now what you can do now for the last question, Anyone solve? Can you solve? Okay. Okay. The thing is, you have squared n plus 1 minus square root of n minus 1 divided by n. If you see any fractions like this, one possible method is try to compare, right? Comparison test. But compare with which function or which series, right? So if you see here, it seems like we have like this square root that has probably it's trouble here, right? Because we have this square root. But notice that we have negative here. Can we try to rationalize this first? Multiply with this couple with positive by positive, and try to change the form. And let's see the form. Okay. So the idea is try to rearrange the formula by rationalize the terms. This is also one way to see whether the series uh, can be observed in more logic sense of manners. So let's try to see the form here. So it will be this squared minus this squared, right? So it's just 1, 2, yeah, plus 1 minus minus 1, so 2, right? Okay. So it's 2 over n, and then you have n plus 1. Now let's say this is our form, okay? Now, because now all n is at the numerator, now we can think some comparison, right? We can think some comparison. But I think because of the square root, maybe if we can think this series here, it's I think it's quite similar, right? What we can do, if you are maybe if you try to find like direct comparison test, maybe you need to test that to prove whether this is greater or less than this. But to avoid that calculation, we can just limit comparison test. So limit the sequence divided by the sequence. Okay. So let's say this is an and this is bn. Okay. Now let's write here a limit as n approach infinity of an divided by bn. So this will be, so this divided by this. So I will move this to the top equation. So I will cancel this. So I will have 2 square root of n at the top. And I have square root of n plus 1 minus 1. Don't forget the limit. Okay. And this will be resulting 2 over 2, right? It's 1. And then because not limit, series of one, this is converge, then the series of the questions of, let's say, the AN is also converge. Okay. So whenever you find like you want to compare with something and you are maybe not really sure whether it's greater or less, you can go to the limit comparison test and you find if it is uh, uh, having the results, then you can uh, check with the other series. If the other series differs, then this also differs. If this is converged, this is converged. Okay. We still have time. I think we can move to the power series. So this is a typical question in your textbook, um, especially in the review part. You can check the review you want. But now let's move on to another question. It's the radius of convergences in power series. Okay, to solve this, first you need to use ratio test, and then you need to assume it will be converged. Okay, so the ratio test should be less than 1, the result. So we can go to ratio test. So first it's ratio test. Okay, now what's your conclusion? Now because this part, the end part, is always 0, so the results will be always 0, right? So this will be 0, and it will be less than 1. So the series will converge for all x, but it will be resulting 0. So the radius of convergence is infinite, and the interval will be this part, the second part. The same thing is ratio test. Then simplify the equation. Now you have okay. 2, 2 here. So this will be resulting 1, right? So it will be resulting 2, and then x minus 3. And to be converged, so to be converged, so this should be less than 1, or this should be less than half. So we can open this, or we can write this r, the radius is half, okay, from here. And we can write that we have this inequality. Okay. This is not yet finished, okay? Because the next part we need to check all x here, all the endpoints. So check when x is 5/2. We get the uh, 5/2. Okay. This will be the result. This is alternate series. And if you check, it's decreasing and its limit is equal 0. So it will be converged by alternate series, right? And check when x is 7/2, it will be 1/n+3, which is diverged, right? Because the p series, right? So the interval of convergence is include 5/2 but not include 7/2. Okay. Any questions? I will go to the next page. Maybe one more problems to solve. Find Mclaren series for each functions and the associated radius of convergence. The functions will be let's try this, just this first. Try this too. I think the easiest one is the right one. Okay. So what you're going to do is first, before you start to have this exercise, remember the 6 functions that we already mentioned in previous lectures. With those 6 functions, if you are changing the or combining those functions with other, then you just need to multiply, or you can divide, or you can integrate, differentiate. Okay. Like for example, this part, you can remember the e to the x. and then you can replacing that x with 2x and multiply with x in the series. Okay. So first, let me try to write down the right part here. So remember that you have e to the x, and you can make out this series from this e, that is x with power of n divided by n factorial, right? So when you have e to the 2x, then what you can do is you can replace x with 2x. Okay? And what you need to do is you need just to multiply with x, multiply with x. So x, this is just 2n x n plus 1, right? And radius of convergence, for this case, if you check, it will be for all, right? Okay, now the left part is ln4 minus x. Remember that if we are deriving this, it will be minus 1 for minus x. Or if we want, we can change these terms with minus. So our equations will be positive like this. So we can write integrations of 1 over 4 minus x dx. This is equal minus ln 4 minus x and then plus c. And we can start to see this form like that. And now you have x over 4, okay? And still in the form of integrations, you can write this and then integrate the series of this x over 4 with power of n. So this will be x n plus 1. And then we have 4n and then n plus 1. And then plus c. Okay, so the ln 4 minus x, the questions, is the negative of all this 1 over 4. Oh, it is already, okay, sorry. Okay, that's We can solve it. Simplify. And if you want, we can shift the n to remove the +1. So we can start from 1 instead of 0 to remove the n+1. So x with power of n for n and then n. And they still have plus c. If x is 0, we get c is ln4, right? From here. If x is 0, it's ln4. So functions, this equal ln4 plus or minus here. And you can check the series here. Check series converge or x over 4 less than 1. Or we can conclude that the radius is 4. And you can check with the ratio test if you want. And it's 4 and 4. This will be 1, and you have 1 over x, and it should be less than 1, right? Okay, any questions? Okay, for the next exercise, I will tell your TA to give your exercise also this Friday, and on Monday, I will have other exercise. Maybe I will go directly with some question from another midterm or another quiz before, or maybe from other class also. Okay, so that's it for today. Any questions? Any questions first? Okay. Okay.